Chapter 5, Section 3, rational numbers. What do you think a rational number is? What's the first 5 letters of the word rational? What does that mean?
It's like a ratio. A ratio.
Well, yeah, you're defining a word with its own word. You can't do that. You can't say like multiplication is like multiplication. You can't do that. What is a ratio? I know we use these words all the time. We know it, we've used them before, but what do they mean? That's the part that leaves us lost. Any guess? Rational? Ratio? Give me an example of a ratio. Go ahead.
Wasn't like 1 and then has a little 2 times.
Yes, that's a ratio. Very good. But now what does that mean? It means this is read 1 to 3.
I remember something denominator could be 0. There's something close to that.
Ratios, rational means fractions.
Yeah.
A rational number is a number that has a finite and terminating decimal. That's a rational number. It has a finite and terminating. What does that mean? Finite. What does finite mean?
Like 1 times 0, like a finite number, like a.
Has an ending. Terminating is just that. Has an ending. It's also actually, or I should say, or repetitive. Repeating decimal. So a rational number is one that's finite and terminating or repeating. For example, if we say 1/3, and keep on going forever. Is this a rational number? Because it's repeating. We know what the next number is going to be in the sequence. If it's a repeating decimal, instead of writing all those, what we write in mathematics is a 3 bar. That means if this bar is on top of it, that means it repeats it. Or if we had a decimal that was, let's say, 25, 25, 25, and so on and so forth, we would write 0.25 with a bar over it. So if it's a repeating sequence of numbers in the same order, we just write that first sequence and put the bar over it. Is this a rational number?
No.
It is a rational number. Isn't that the same as this? So that equals 4.0. Since it's 0.0, we just write 4. Every number is at least a rational. You can make it a fraction.
question?
Yes,
Then, yes, rational numbers are fraction. But if you're saying rational numbers are repeating numbers in the same,
in the same sequence,
so.
like
how would
1
that-
over
would that
3.
be Like 4.0, how would that be? It's still a rational number just because.
Because it's terminating. It ends. There is no,
So it's either.
yeah, it's the or statement.
Mhm.
It's finite terminating or it's repeating. I'm sorry, it's finite terminating or repeating. So we know we have rational if it has the same numbers over and over, or it has a set number of them, or it doesn't have any. Those are all examples of rational numbers. If it's not rational, it's what? Irrational. I see, mathematically, that's a valid definition. An irrational number. This is section 4. It's hard to talk about one without talking about the other. So an irrational number is a number that is not rational. So if it's not rational, what does the number look like?
Would it be the inverse of that?
Which would be what?
Are we going with number 4?
No, we're looking at the definition of rational numbers. These are just examples. This is the definition you have to look at. An irrational number is just the opposite of this. So it would be what? 1.2 is a terminating decimal.
Oh, would it be zeros in front of it?
Well,
0.12, whatever?
I'll show you. An irrational number is a number that has an infinite and non-repeating decimal. It's just the opposite of the other one. Remember, the rational was finite and repeating. So the irrational is the opposite of that, infinite and not repeating. The most common one we know is pi. Another one we know is radical 2. Okay, so let's talk about rational numbers. That's our first topic. So these are the opposites of each other. Rational numbers are finite and repeating. Irrationals are infinite and not repeating. Simplifying rational numbers. So what would we do here? How would we simplify this rational number? Yes, we can do that. So what you're getting at is, let's see what they have in common and reduce. So what we should do first is take both of these numbers and try and factorize it. So what is 24 made up of? Well, yeah, it ends in an even number, so it has 2 in there. 2 times 12 is 24. Can't go anywhere with 2. What is 12 made up of? 2 times 6. And 6 is made up of? Yes.
Like 4 times 3 wouldn't work.
It would work also because so if we had 12, if we did 4 times 3, 4 is made up of 2 times 2. So 12 is made up of 2 times 2 times 3. 2 times 2 times 3. So yeah, either way, at the very end, we'll get the same answer. This is called prime factorization. Taking a number down to its smallest prime numbers. Remember what a prime number is? Remember what a prime number was? Prime number is a number that is only divisible by 1 and itself. A prime number is a number that can only be divided by itself or 1. Next, 3. What makes up a 3? 1 times 3, nothing else. But what makes up a 4? 1 times 4 or 2 times 2. So those are what we're looking for. We're prime factorizing that. We take it down to its smallest numbers. So 24 is made up of what? 2, 2, 2, and 3. So it's 2 times 2 times 2 times 3. How about 38? What is it made up of?
2 and then 10.
Right. So we know 2. That's what you were working on. So let's see. We know 2 goes in there because the number 8 ends in an even number or 0. 2 goes into 3 how many times? Once. With how many left over? With 1 left over. And 2 goes into 18 9 times. So 2 times 19 is 38. 2 is a prime. Well, 19 is a prime number also. Now, since we're simplifying, we cancel whatever is the same. Whatever's left, we multiply. 2 times 2 is 4, times 3, 12 over 19, and that's the simplified version. Make sense? We'll try a bigger number or another small one.
Small one first.
Okay. Let's do this one. 42 divided by 68. That's what. No. So the first thing we have to do is find what makes up 42 and 68. So what do we know goes into 42? 2. We know it because the last number is an even integer. 2 goes into 4 twice. 2 goes into 2 once. So that's as far as that one goes. How about 21? Very good. 3 is a prime number. 7 is a prime number. So 48 is made up of 2 times 3 times 7. $68. We know 2 goes in there because it ends in an even integer. Yeah, 2 goes into 6 3 times. 2 goes into 8 4 times. 34 again ends in an even, so we know 2 goes in there. 2 goes into 3 once with 1 left over. So 2 goes into 14 7. And 17 is a prime number. Anything cancel? The 2's. We're left with 3 times 7 is 21. 2 times 17. And there's your final answer. You can't go any further because if you could simplify it, you do it here. After you finish this, whatever's left is the simplest it can go. I'll show you. Let's look at these two. Yeah, so when we say 2 goes into, that's 32 divided by 2.
Right.
That same thing. So 2 goes into 3 once with 1 left over. 2 goes into 12 6 times. 16 is 2 times 8. 8 is 2 times 4. 4 is 2 times 2. 1 2 3 4 5. These are the nodes. You count those go up here. Do the same thing with 128. 2 goes into 12 6 times. 2 goes into 8 4. 2 goes into 6 3 times. 2 goes into 4 twice. And we just did 32. So we know 1 2. And then these 5. Since I already did these, I could just put it there. Reduce. The 2's cancel, the 2's cancel, the 2's cancel, the 2's cancel, the 2's cancel. What are we left with? What's the final answer? Okay, we have so far we had 4. We have 0 over 4. What else? 1 over 4. Yeah. What else? And the answer is 1/4. The reason being because every number is multiplied by 1. And if you had 0 up there, the answer would be 0. And yes, there are 4, but it's on the bottom, has to stay on the bottom. So that one's wrong. So yes, there's one left on top, and 2 times 2 is 4. You have more confidence in yourself. So that's how we reduce rational expressions, fractions. And also what we could have done is, you see how we got here 32? And this one was 2 times 2 is 4. 4 times 32 is 128. We could just canceled these two. So we could have had 2 times 2. Or we should have 32 on top of this one. And then 2 times 2 times 32. The 32's cancel. Once you see a common number, you're done. Leave, so it's 1/4. But whatever method works for you, do it that way. I'd rather have a right answer than getting confused. Okie doke. Let's talk about the 2 different types of rational numbers. Remember, a rational number is a fraction. A fraction has a numerator over a denominator. We'll call this one N, and we'll call this one D. If D is greater than N, if the bottom number is larger than the top, it is a proper fraction. If the bottom number is bigger than the top, 1/4, 9/11, 17/50. Those are all examples of proper fractions. If the bottom number is bigger than the top, that's it. If the denominator is big, bottom is bigger than top. That's a proper fraction. So if it's not proper, it's called a what? Improper. Very good. So that means if the numerator, the top number is bigger than the bottom, it is an improper fraction. (11/9), 50/17, 4. Those are all examples of improper fractions. Why is 4 an improper fraction? Very good. Because it's 4/1. And that brings us to a rule. As a rule, you never want to leave an answer as an improper fraction. That's a rule. You never want to leave your answer as an improper fraction. So we convert it into a mixed number. You never want to leave an answer as improper, so we convert it into an improper, into a mixed number. A mixed number looks like this. It has an integer, a number, and it has a fraction. It has an integer in front and a fraction behind it. A proper fraction behind it. For example, that's an example of a mixed number. It's mixed because it has an integer and a fraction. So let's look at 11 over 9. That's an improper fraction. So the easiest way to convert this one is, let's just do the division. How many times does 9 go into 11? 1. 1 times 9 is 9. 11 minus 9 is what? 2. And those are the pieces we need. The top number here is the integer part. The bottom number here is the numerator. And this number here is the denominator. 1, 2 over 9. The denominator has to stay the denominator. Let's look at another one. Yeah, we'll do about 3 or 4 of these until you get comfortable doing these. Remember, if you have a question, don't just try to figure out in your head, ask. Because I'm going to keep on moving and you're going to be stuck and miss the rest of the discussion. So if I lose you, stop me. $63 over 15. Is it an improper fraction? Yes. How many times does 15 go into 63? Yeah. 4 times. Because it's 15 plus 15 plus 15 plus 15. That equals 60. Yeah, the faster you work on your multiplication skills, the easier it is for you. 4 times 15 is 60. Subtract those, you get 3. So the mixed number is the integer, the numerator, and the denominator. Are we finished? No, because this can be simplified.
Oh, you still have to break it. Okay.
Take it as far as you can, because we could have simplified this one. Well, that's what I'll do next. I'll show you that one. What number do they have in common? Well, it has to be because 3 is a prime number. 15 is made up of 3 times 5. So the threes cancel, leaving us with what? 1/5. And there's your final answer. Let's look at 63/15. I know they both, how do I know they both have a 3 in them? Remember that sheet I gave you all last week, the division sheet?
Yeah, it's the three. Like 6 plus 3 is 9.
Exactly, yes. If you add up the digits, 6 plus 3 was 9. 9 is divisible by 3. So that means this number is divisible by 3. 1 plus 5 is 6. 6 is divisible by 3. So this number is divisible by 3. So we know that they both have a 3 in common. 3 goes into 6 twice. 3 goes, what? 3 goes into 15 5 times. So this number actually becomes 3 times 21, 3 times 5. Can't go any further, but it's an improper. How many times is 5 going to 21? 5 times 4 is 20. 4 and 1/5. Same thing. So if you simplify first, it'll make your whole thing easier. If not, then you have to keep on simplifying the fraction part, the rational part.
Question,
Mhm.
what I'm understanding that it's something I'm about to think wrong.
Mhm.
That right there, 5/21.
Right.
Or that 5 was left over 1.
Right.
I would have kept going. I think I'm mixing something up. I would put a 0 down there.
No,
5 goes into 10.
1/5 is a proper fraction.
I would sit down.
Once it's a proper fraction and they can't be simplified, you're done. How about that one?
Well,
It's a proper fraction, but can you simplify it? What do you mean, no? They both ended in even numbers, so they have a what in common? Yeah, they have a 2 in common. Two goes into 2 once, 2 goes into 8 4 times. Two, 2, and 7. And then 36. 3 goes into 3 once, 3 goes into 6 twice. So it's 2 times 2 times 3 times 3. What do you do next? Reduce, yeah. So what you have left is 7/9, and that's as far as you can go. That's your answer of that one. How would you solve that one? Besides waiting for me to do it.
Wouldn't it just be like the one in the bottom, which is good? The 790.
Very good. But yes, it would be, but you still have to do the same thing. You have to simplify it. You'd end up with 2 times 2 times 3 times 3, 2, 2, and 7. We just did the numbers. Yeah, so we'd end up with 9/7. Very good. Good observation. So now we just do this division. How many times does 7 go into 9? With how many left over? Because the denominator has to stay the denominator. 7 goes into 9 once. So there's your integer. There's your numerator. And there's your denominator. So far, so good? So yes, with improper fractions, you have to do both the factoring part as well as division part.
Improper fractions, denominator must remain the bottom.
Right, yeah, once you simplify it, the denominator stays on the bottom. Right. All right, what if I gave you this? What if I gave you an mixed number? I want an improper fraction. Convert from mixed number to improper fraction. Here's the formula. This is a mixed number. Remember, the bottom number has to stay the bottom number, so that's easy. To get to the top, multiply a times the denominator and add the numerator. That's the formula. Denominator stays the denominator.
So if that's the case, that means 5 times 3.
Yeah, a times y is 3 times 5
And then
plus 2. 3 times 5 is 15 plus 2, which is 17/5. There's your conversion. Why would you want to convert a mixed number to? Good morning. So why would you want to convert from mixed number to improper fraction? Actually, you want to take pictures of these notes and everything? Here, you want these notes? Take pictures of them?
Okay,
It'll make it easier for you.
thank you.
Why would we want to convert it from mixed number to improper? It'll help us when we do the next parts, which are multiplication, addition, subtraction, division of fractions. It's much easier to put it in this form and then work it out and then simplify it again. What if I gave you this number? Give me that number as an improper fraction.
Rule range.
31%.
No,
No,
no.
thank you.
You're very welcome.
Negative 31?
Negative 31/7. Yeah, the number's negative. You gotta say negative. You didn't see that negative? Yeah, so if it has a negative in there, don't do a lot of people, the mistake people do is -4 times 7 is -28 plus 3 is -25. No. This negative stays out in front. Then we do the 4 times 7 plus 3/7. So this number doesn't belong just to the 4, it belongs to the entire equation.
The rule remains the same. It's negative.
Yeah. And that's what I'm trying to get to a point, and eventually I want you to start seeing, treat the signs and the numbers separately. Well, like when we did the addition subtraction rules, treat the signs and the numbers separately, and then you'll never go wrong with the signs. You didn't see the sign. So 4 times 7 is 28. Plus 3/7. -31/7. Now, if you have a negative in front of a fraction, you can leave it like that, or you could put it with the numerator. The negative never goes on the bottom. And we're going to show you that when we do addition and subtraction of fractions.
Either or, I got you.
Yeah, these are both the same thing. Okay. Oh. We know that if we have a fraction and we do this work, you can rewrite it as a decimal. Yes. You guys are going to jump in a calculator. We're going to give you a decimal. But this is what's really happening. If the bottom number is bigger than the top, does 4 go into 1? No. So once we put a decimal there, we added a 0. Does 4 go into 10? Yes. How many times? So 2 times 4 is 8. Subtract those, you get 2. And since we're going to the next number, we put a 0 there. How many times is 4 going to 20? 5 times 4 is 20. So the answer is 0.25. Or if you want to, you can put 0.25. If you think about it, if you take $1 and divide it by 4, what do you get? A quarter, which is 25 cents.
So what we're doing with this one here, that's what my mind was going, but I messed up this. This now is converting
We're converting
from mixed number to an improper fraction.
what a proper, no, this is mixed number to improper.
Okay.
This part we're doing now, we're actually calculating the fraction and coming up with a decimal.
Okay.
Because what we're going to do next, remember, we have to go both directions. Then we're going to go from decimal to a fraction.
Okay.
All right, so let's do another one. 3/5. What'd you get? Yes. Very good.
What's he saying?
She says she got 0.38. No, she got 0.6.
Oh, I said, I was.
Okay, let's look at this. So 5 goes into 3. Does 5 go into 3? No. So we put a decimal and we got to put a 0. 5 goes into 30 6 times. So it's 0.6.
So it's not 0.06. This is
0.6. Yeah. Once we put a decimal there, that adds a 0 to the number. Now, there's another way we could have done that. What is 3 divided by 10? When it comes with numbers like 10, 100, thousands, since our numeric system is a base 10, it's a numeric decimal system. Each step you move is tens. So 3 divided by 10 is 0.3. 3 divided by 100. Here's a decimal. 100 has 2 zeros, so it's 1, 2. So it's 0.03. 3 over 1,000 would be what? .003. Because we start off at 3.0, we move it 3 spaces. 1, 2, 3. So we have 2 zeros in front of it. So in other words, each space we move it to the left, that means we divide it by 10. What's 100 made up of? 10 times 10, right? So divide it by 10, divided by 10 again. 1,000 is 10 times 10 times 10. 10, 10, 10. That makes sense? What if I had 42 divided by 10? What would that answer be? Oh, no. 4.2. Because where's the decimal in 42? After the 2, right? We divided by 10, so in 1 space. There goes your perfect score. Now, why am I getting to this? Let's look at these last 2 examples we did. The 1 over 4, 3 over 5. One over 4. If we can we get it to either a 10 or 100? So can we go from 10 to from 4 to a 10, or can we go from 4 to 100? Your multiplication skills. 4 times what gives us 100? 25. So if I multiply the top and the bottom by 25, I get 25 over 100. Since it's over 100, I move the decimal place 2 to the left, I get 0.25. So again, as you don't have to do the division, you could just do the multiplication. Get the bottom number to be either 10, 100, 1,000, or whatever, and then multiply top and bottom. 3 over 5. What can we get 5 to? Can we get it to be a 10? Yeah. How do we get it to be a 10? Multiply by 2. So we do the top also. 3 times 2 is 6. So the answer is 0.6.
So we're at the bottom.
What's 4 over 25? But we has to be either 10, 100, or 1,000. Remember,
Four.
it could be 100. Yeah, by multiplying by 4, right? We get 25 to 100 by multiplying top and bottom by 4. 4 times 25 is 100. 4 times 4 is 16. Move the decimal 2 to the left. So the answer is 0.16. That's if you can get the bottom to be as a 10, 100, or 1,000, or anything like that. Any factor of 10. Everybody okay with those? Let's go backwards. If I gave you 0.6, so I'm going from decimal to fraction. If I give you 0.6, what is that in a fraction world? Well, we have a 6. How many spaces do we have to move the decimal? Yeah, exactly. Good. It's 1 space, so it's a 10. Can you simplify 6 over 10? It becomes what? Yes. Yes, you can. So yes, because they both have a 2 in common. 2 goes into 6 3 times, 2 goes into 5, a 10 5 times. So the fraction 0.6 is the same as 3 over 5. What's 0.33 as a fraction? Very good. Since it's 2 spaces, it's over 100. That can't be simplified, so 33 over 100. Very good. Are those proper or improper? How do we know if they're proper or improper? What's that?
The bigger numbers at?
Well, either one of those. They're both, are they proper or improper? Why? Yes, because the bottom number is bigger than the top. But how do we know this is a proper fraction? What's the definition of proper fractions? If it's a proper fraction, your decimal is either finite terminating or repeating. This is finite. It's only 0.6. So because of that, it's proper fraction. It's a rational number. How about this one? Same logic. Ooh, what if I gave you 4.5? Convert that into a fraction. Right? 45, since it's only 1 decimal place, over 10. Can we simplify? It becomes what? What do they both have in common? A 5. 5 goes in, let's see. I'll do this the long way. 45 is made up of 9 times 5. 9 is 3 times 3. 10 is 2 times 5. So we got a 3 times 3 times 5. 2 times 5. The 5s cancel, leaving us with 9 over 2. Improper or proper? Improper. So if it's improper, we have to convert it into what? Mix. We can't. Yes, we have to convert it to a mixed number. How many times does 2 go into 9? 4 times 2 is 8. So it's 4 and 1/2. Yes, go ahead.
I'll just look at it. Okay, so basically there was 2.5, there would be 25 over 100. You're trying to see.
Let's do that one. If it was 2.5, since it's only one decimal place, it would be 25 over 10.
I was gonna say 10, but 10, go ahead.
Okay, then from there we can simplify. 25 is made up of 5 times 5 over 2 times 5. Two goes into 5 twice with 1 left over. So how? It all depends on how many spaces you have to move the decimal to get it behind the last digit. Since I only moved it once, basically every space you move it, you put another 0 on the bottom. Convert that one to a fraction.
That'd be 4 over.
Yeah, so
4 over 100.
count how many spaces you move it. 1, 2, 3. So it's 3 zeros.
Right, because they'd be behind 4.
Has to be behind on 4. And they can be simplified. What do they both have in common? Two, yeah. 2 goes into 10, 2 goes into 4 how many times? 2 goes into 1,000 how many times? In 500, 2 goes in there how many times? And well, since we only have 2 2s on top, once I find 2 2s, I'm fat, dumb, and happy. So 2s cancel. So we get 1 over 250. So far so good. So let's look at these also. We have proper fractions and improper. Numerator over denominator, numerator over denominator. So in a proper fraction, which one's bigger, top or bottom? Yeah, so the denominator is bigger than the numerator. Since the bottom number is bigger than the top, this number has to be between 0 and 1. It's always going to have a decimal, whatever. An improper fraction, the numerator is bigger than the denominator. Because of that, this one's always going to be bigger than 1. Or they can equal 1 if they're the same. But proper fractions will always be a decimal, meaning between 0 and 1. Improper fractions will always have an integer that means bigger than 1. All right, now the tricky part. If I have, yeah, I have time. This one goes on forever. It's an infinite number, but it's the repeating decimal. How do we convert that into a fraction? This is a 3-step process. First step. Since each of these only repeat in steps of 1, it's all 6, 6, 6, 6, 6, 6, 6, 6. Multiply by 10. I'm going to say this number is equal to x. X is equal to that number. If you take this number and multiply it by 10, what do you get? If you multiply this number by 10, what do you get? Well, 6 divided by 10 would be what? In decimal. Yeah, you move to the left. When you divide, you go to the left. So when you multiply, which direction do you think you go? To the right. So this one would give us 6.66666. So far, so good. So in other words, we have to get a first number of the repeating numbers in front of the decimal. We do that by multiplying by 10.
That's the
Well, I'm showing you. Step 2. Subtract by x. Multiply x by 10. So here I subtract by x. What is x? X is 0.66666. So if I subtract these, 10 minus 1 is what? 6.666 minus 0.666. What cancels? All the decimals. So we're left with this. Now we can solve for x. How do we solve for x? By 9. We want to get x by itself, so we have to get rid of the 9. Since it's multiplied to x, we do the opposite. Divide both sides by 9, these cancel. 6 divided by 9 becomes 2/3, and there's your fraction. Then that's step 3. Step 3, divide by the coefficient, the number in front. We divide by 9. We'll do one more example, then I'll kick you guys out. Because next week we'll go over the procedures on how to do what these are called one-step problems, and then we'll finish up this and look at irrationals also. Okay, let's look at another repeating number. What if I gave you the repeating number 0.25, 25, 25, 25? What is this in a fraction form? No. 1/2 would be 0.5. 1/4 would be 0.25. Nothing else. Let's see. Are these repeating terms? They're repeating what? 2 steps, right? So remember, this is X. So what do we have to multiply to get the first repeating terms in front? By 100, because it's 2 steps. So we multiply by 100, both sides. When you multiply by 100, you move 1, 2. That gives us 25.252525 ... So if they were repeating in groups of 3, 168, 168, 168, you'd multiply by 1,000. Yeah. So however many digits that are repeating, that's how many zeros you're going to have. You're going to multiply it. Since the last one was only one number, 6, 6, 6, 6, 6, we only multiplied by a 10 with one 0. What do we do with this number now? Subtract X, which is 0.252525 ... 100 minus 1 is 99x. The decimals cancel. Get x by itself. Divide both sides by 99. There you have it. There was a good guess you made earlier, because yes, 1/4 is 0.25, but because it happens all the time, 0.25, 0.25, 0.25, 2.5, it can't be that. This is a non-terminating repeating number. Okay, the next time we're going to talk about adding, subtracting, multiplying, dividing rational numbers. And then if I give you 2 fractions, can you find me a number between those 2? That's called the density number, or density of fractions. And we'll do that next time. Okay, everybody have a great, safe weekend. And be careful tonight because it's supposed to be